Hello, everyone. You are welcome once again to today's lesson. And in today's lesson, we are going to look at the continuation of algebra of what functions. So we are still on functions. So this would be lesson 3 of what functions. Okay, so let's see. In our previous lesson, we were still dealing with the algebra. However, we did addition and subtraction and multiplication. In today's meeting, we are going to look at the last operation, which will be what? Division. So please stick and stay with me. And as always, okay, don't hesitate to let me know at a point that, okay, I say something, I write something that you don't really understand. Put up your hand. You'll be given the opportunity to let us know what your problem is. And I will always be there to explain. Okay, once again, I'm Mr. Hackman, and I am, okay, going to walk you through the lesson today. Okay, so quickly, let's look at our third example on the algebra of functions. Okay, so as usual, we've been given these three functions. Okay, function f, j, and what? And h. Okay, and what are we supposed to do? A, we are supposed to find the function f of x divided by the function g of x. B, function g of x divided by the function f of x. Okay, then C, function f of x over h of x. And you should know that this is basically the same as divided by h of x. Okay, D and E with the corresponding, and anytime you see red, it means it is no go area for me. It will be for you. Okay, so take note. And please, okay, if possible, okay, turn off your video. Okay, apart from the fact that it will save you data. Okay, please. Okay, I want all of you, your concentration to be here. Sometimes the video, okay, distracts, okay, some of you. So please, if possible, Prof. Rosemond, kindly turn off your video, if possible. Is that okay? Thanks for your understanding. All right, great, wonderful. So now let's go and look at how to present the solution. Okay, we know that anytime a question is given, okay, the first thing that we do is to read the question and then underline the salient parts, if any. But remember, I told you in terms of the salient parts, when you see true sets, when you see approximation, when you see hence, when you see prove, when you see show, but we can't see any of that here. Or when the question asks you to leave your answer in a form, you underline the form, but we don't see any of such here. So in that case, we don't have any salient part to underline in this question. After that, what you go and write first is solution. So after reading the question, the first thing that you write will be solution. And please take note, I've told you, it is not your business to write all the questions and capture it for me. Okay, what I need is the solution. I need the solution. Okay, I've told you that if you want to write a question, fine. But make sure you write all the questions before you give me all your solutions. Don't write the questions in isolation. So in this case, I don't need the question. The question is already here. I write solution, having realized that there is no salient part to underline. Okay, I write solution. Questions are usually numbered because we also want you to number your solution. So in this case, okay, my major question number is 3. So I write, okay, solution to question 3. So I write 3 as well. And if you look at 3, where I have the question number 3, that's where my functions are given. So when I'm extracting the function, the question number that will be attached to that extraction should be 3. Please take note. So if this was A, then in that case, I would have written, okay, A here and extracted my function. So remember, after writing the question number, okay, we extract what we will need, and in this case, the functions. So given, okay, the functions are in which form? The whole class, the functions are in which form? If you know, you can.
The mapping form.
The mapping form. However, I said,
mapping
okay,
form.
which form do we extract functions? Mapping or relation form?
Relation.
Relation. Okay, so going forward, I know some of you are still doing going forward from today. Make it a point not to, okay, lose the mass for that. Okay, not to do the writing. So at this point, my first function, f of x, okay, I mean, f is such that I'm going to extract it in terms of its relation form. So it will be f of x, okay, is equal to, and that will be x squared, okay, plus what? X. Okay, then which other function I've been given g of x is equal to, and what do I have? X squared, okay, minus 1. You can see that I could have brought this one down, this g of x here down, but I didn't bring it down because I realized that I still have room, okay, for that. So my point is avoid extracting the information in the column form or column wise. Okay, if possible, extract it, okay, row wise, because now you are using constraint paper. Okay, after the first break, our water break, I will show you the nature of what a constraint paper, where you are provided a space to, okay, give your solution. So this will be it. And okay, we have our last function, which is h of x. And that is equal to, so now that I've exhausted this line, I can come down. Please take note. So that will give me 2x squared, okay, minus x, then minus 1. Okay, so we are done. So now we come to A. So this is a general information that we are going to rely on to solve A up to what? Up to E. So at this point A, what are we giving? We are supposed to look at f of x, okay, divided by what? J of x. All correct? And you can see that after writing the A,
Yes, sir.
I didn't write equal to. I didn't write equal to because I am going to solve this. Whatever you are going to solve, you are asked to deal with. Okay, that's what, okay, you need to extract first. And you can see there's like copy and paste. Exactly what I have here is what is written here. So it's now that your input is going to come in. And because this is an expression, anytime I'm going to, okay, do something to what I have there, okay, which indirectly would be a step, I introduce the steps with what equal to. This is an expression. You don't introduce steps of expressions with the implication sign, never. Okay, now, okay, you are matured. You know when to use the implication sign and when to use the equal to. We said implications will be for, okay, equations and inequalities, and equal to will be for expression. And this is an expression. It doesn't contain equal to, it doesn't contain any of the inequality signs. So we start introducing our steps each way, each step on the way must be introduced with equal to. So your first step, this is what you do. Anytime you are asked to divide, please take note. If you see the division symbol, change it to what? The division bar. Okay, so meaning what I have here indirectly is the same as this, what I'm going to write, f of x, okay, over j of x. As you mature, you won't write this. You move on to the next step that I'm going to write. So this will be equal to, what is our f of x? Okay, f of x is what? X squared, you have it here, s squared, okay, plus x. Am I right? Over, what is our g of x? G of x is what? S squared minus 1. All correct? Okay, so
Yes,
now
sir.
at this point, so all of us, we should be able to write it and get the marks up to this point. Okay, because this one, little or no input, is just substitution. Okay, at this point, this is where you have to be very careful. Anytime you are giving, okay, a rational expression in the sense that you have an expression over another expression, please check whether that expression can be reduced. And if that expression can be reduced, okay, you have to factorize both the numerator and the denominator if possible. Should I come again? Or my point is well made?
Yes, please.
I should come
Okay.
again?
Yes, please.
Okay, so I said, as for up to this point, we are all fine. Is that not it? We are all fine. Is that not it? Up to this point, great. Okay, so here I said, you cannot end here because usually anytime you have a fraction, assuming maybe I want to explain from the known. If I have 4 over 2, can I end, okay, here? Can I end, okay, or conclude with 4 over 2 as my final answer?
No,
No. What do? You simplify, is that not it?
Yes.
Very good. Meaning you reduce it. And if any fraction, okay, can be reduced, then, okay, you should see, okay, one as a factor of the other. In that case, it means, okay, it can be reduced. Other than that, it cannot be reduced. That's the more reason why if you have 7, okay, or let me write 5 on 7, you leave your answer like that because this cannot be reduced. Okay, however, in this time around, we are not dealing with numbers. We are dealing with expressions. Okay, so please take note. Anytime you encounter any issues, which is personal, okay, maybe you are not able to see my screen, what I have shared. You are not able to hear my voice. Okay, please, if it's not general, if it's not a general concern, then it means it's a particular concern. Always disconnect and reconnect and see if you come back with a better, okay, network. Please take notes. Okay, all right. So poke your end where you can disconnect and reconnect. Okay, so now, like I was saying, again, for this a rational expression, this what you have here is a rational number. Okay, a number over another number, an expression over another expression, a rational, okay, expression, a function over another function, a rational function. Remember, okay, maths, we just play with words. Okay, that's all. So in this case, this is what we have. Okay, and I said for you, you can't end here because if, okay, this can be reduced, you can only determine that fully, okay, or convincingly when you are able to factorize the numerator and the denominator. Okay, when you express both the numerator and the denominator in terms of products, and product means factors. So it's the same thing here. If this can be reduced, you know that the numerator will be 2 times 2 all over 2, and this 2 will cancel, and that will give you the 2. But usually we don't write it this way. We know that this will go here too, then you write it. But that is the meaning. You write this as a product. So if you had maybe 6 over let's say 3, this would have been 2 times for 3, then all over 3. And this will cancel, and that will give you the 2. Because you're able to reduce, and you can reduce because, okay, the numerator, okay, could be expressed as factors. In the same way, this numerator, we can express it as factors because, okay, it is factorable. Same for the denominator. So at this point, I've made my point. So I am going to, with this, I'm going to clear this. Okay, and I've told you, anytime you move from one line to the other line, make sure you write close to the margin. So you can see that that's exactly what I'm doing. Okay, when I move from this line to this line, okay, I wrote close to the margin just to create room here for my rough work if need be. Take note. So in this case, this is what you do. Okay, in factorizing the numerator, I will just need a step to factorize. I can factorize this by writing x into x plus 1. Do you agree?
Yes, please.
Okay, the denominator
Yes,
is
please.
also factorable. Okay,
Yes,
what
sir.
technique of factorization are we supposed to use here to factorize the denominator? Any help? Which technique of factorization? Okay, Prof. Peter.
Difference of 2 squares.
Perfect. Okay, so difference of 2 squares. So we know that this is the same as what? X squared minus 1 squared. And remember, we said anytime you have when a squared minus b squared, this will always factorize into your a plus b, then into what? A minus b. However, in this case, our a is x, our b is 1. So it means if you factorize, okay, we are going to get x, which is our a plus b, which is 1, into x, which is what? Our a. Okay, then minus what? B, which is 1. Is my point well made here?
Yes, sir.
Yes.
Okay, so now, because, okay, your numerator, okay, you've written it out as product. So this times this is a product. This also times this is a product. Both the numerator and denominator expressed as factors product. So in this case, once you are able to do that, it means you can cancel. And please, you should know at this point that the s squared here cannot cancel this s squared because, okay, you have, okay, plus sign between what you have there. The s squared here is not a factor, it is a term. Okay, so you can't cancel, you can only cancel factors, not terms. Is my point well made?
Yes,
Yes.
please.
Okay, so at this point, we know that we can cancel this and cancel this as well. And it's not necessary to show your cancellation. You can cancel mentally and write your result. So I know that the next that I'm supposed to get. My numerator will be left with x over my denominator. My denominator will be left with x minus 1. All correct?
Yes, please.
Okay,
Yes,
so at this
please.
point, we can comfortably have our conclusion drawn. So it means therefore, okay, and you conclude with what you were given, not what you have transformed. So you cannot come and write therefore this is equal to therefore what you were given, which is what? What do we have? F of x, okay, divided by g of x, okay, will be equal to x over x minus 1. Is my point well made?
Yes,
Yes,
please.
Okay, however, please take note, just as I told you, okay, when you are dealing with functions, anytime you are dealing with functions, okay, and your resultant function has a variable in the denominator, okay, if possible, okay, let us know the restriction in or for the variable, because you know that for any fraction to be defined, the denominator should not be equal to 0. So here, my denominator here, which is what? X minus 1, should not be equal to 0. For my denominator not to be equal to 0, I will get x should not be equal to 1. So usually it's better you attach that x not equal to what? 1. Because if x is equal to 1, your denominator will be 1 minus 1, which will give you 0. And that will make this undefined. Should I come again, or my point is well made?
Yes, please.
Okay, so don't worry. Okay, you know, anytime you have a fraction, a rational number, usually we say the rational number is any number that can be written in the form a over b. We don't end there. If you end here, you won't get the mass. There is a condition: b should not be equal to 0. Is that clear?
Yes, please.
So it's the same condition that I'm using here, because my denominator, okay, contains a variable. It means my denominator, okay, will have a variable that will make it restricted. Okay, so there is restriction on my denominator. And how do I get the restriction? We said just come and set x minus 1 not to be equal to 0. So your denominator x minus 1, because it's like now the whole of this is your b and this is your a. Do you agree? This is a over b. So you said the condition is that b should not be equal to 0. So your b is x minus 1. It shouldn't be equal to 0. And you solve for the x. So if you solve for x, x will be here. Then you move this 1 to the side, which will give us x not equal to 1. Is that clear now? And that is what you come and attach here. Okay, making this a complete, okay, fraction. So meaning this fraction will always be defined if x, okay, is not equal to what? 1. But if x is equal to what? 1, what you have here will be undefined. I guess my point is well made now.
Yes, please.
yes,
Okay,
please.
very good. And if this happens to be your rough work, any rough work that you do, make sure you don't forget to strike it out. Very important. However, I've told you, cancel it, okay, in such a way that it will still be readable. Okay, and that's exactly what you can see, that in my cancellation, what I have there is still readable. So if there are any marks for this, I can get it here as well. Okay, are we all fine? Before we move on to B, our second one. Okay, any questions? Remember, I've told you, this is where you need to ask questions, especially nobody sees you. Okay, so you shouldn't be shy of any, I've told you we are a family. In any case, we shouldn't be shy of each other. Okay, Prof. Agnes.
Please, Mr. Hakma, I didn't really get the substitution.
Okay, from here.
From the beginning, the substitution. I didn't start the class, so
Okay, so if that's the case, then you have to wait for the video. Other than that, it will not be fair. You get it?
okay.
I believe in fairness. It will
Yes,
not be
please.
fair. Okay, so that next time you will be compelled to come or encouraged to come what early. So you wait, or you wait for the next example. Maybe that concern will be addressed. Is that clear? Okay, great. Thanks for your understanding. So B, what do we have? Okay, B. We are looking at g of x divided by what? F of x. So I will write this time. I know that this is the same as my g of x which is what? S squared minus 1 all over my. So you can see that this time around, I didn't write this, so I skipped this step, just as I said. You get it? I've told you that for you to get the simplification fully done and correctly done, you must always change this division symbol to the division bar. And you can change it at this point where you are carrying out your substitution. So this will not, attract any marks because that's, could be skipped. So now what do we have? Over your f of x. And your f of x will be, what is f of x? F of x is s squared plus what? X. So that is what you write there, s squared plus what? X. Okay, please, are you fine now? Especially the one who was not with us from the beginning. Now, you appreciate the substitution, right?
Yes, please.
Very good. So like I said, okay, so now this will be it's equal to, and this is also an algebraic what do you call it? Fraction or a rational expression. And once it's a rational expression, you should know before you can comfortably say that it cannot be simplified. Numerator and denominator must be factorized. And we know we've done the factorization of this. We know this will give us x. The numerator factorizes into s plus 1, x minus 1 by using difference of two squares factorization all over your denominator, which we said will give us x into what? X plus 1. Is my point well made?
Yes, please. Yes,
Okay, great.
please.
All right. So at this point, we are more than good to go. So we know we can now reduce by canceling. I said you can choose not to show your cancellation. This is SHS, so you can do that. So here your numerator will be, this will be 1. So 1 times this will give us x minus 1 without the brackets. Okay, the 1 is simply understood to be there. This will also go, so the denominator will be left with x. At this point, we could have drawn our conclusion. Okay, so now I am going to write therefore what I was asked to find, which is g of x, divided by my f of x, will be equal to x minus 1 over x. Is that all? Hello, can we end here and get the full marks?
No.
No, so what is left?
Probably.
What is left?
The constraint.
The constraint, very good. So you remember here, there is a variable in the denominator. If the denominator was just a number, then it means there is no constraint. Once you see a variable in the denominator, it means that variable sort of must be restricted. Okay, so here we know for every fraction to be defined, the denominator should not be equal to 0. So here you know that the denominator will give us x not equal to 0, and s is already solved for. Unlike the other one that you know. Okay, after equating, writing x minus 1 not equal to 0, x was not explicit. So you have to make x a subject. But here, after equating to 0, x is already made a subject. That's why you were able to attach that straight away. You see the difference?
Yes, please.
Great. All right. Okay, so that will be it for B. Okay, now we are going to look at that of the C and D. But before that, any questions? Any questions? Oh, we thank God you are all fine. Okay, Paula, are you there? Prof. Paula, are you there? Please unmute and respond if you are. Okay, so now let's see. What are we giving? We've been giving, this time right, is f of x, over what? H of x. So here the division bar came straight away. Okay, so in the form that we want, so direct substitution. So f of s we know is x squared, plus what? X over h of s, and h of s we all know is 2x squared, minus x minus 1. So direct substitution. As for this particular step, we should all get it right. It is just copy and paste. Okay, the numerator function, the denominator function, and that will be it. Okay, we can see that the numerator function, you need just a step, to factorize. So here we have, we know that this will give us x into x plus 1. We already know that factorization. We've done that in A and what B. But the denominator, okay, we cannot factorize straight away. Okay, meaning the factorization will not be, okay, just a step. It will involve more than a step. And whenever you encounter this situation, don't come and factorize, okay, here. Pick whatever that you need the factorization, which you know will be more than one step. Pick it, come and factorize as your rough work and import the result. And I will tell you, okay, the reason, the simple reason for this advice. So now let's do that. Okay, so in this case, I'm going to factorize what? Okay, 2s squared minus x minus 1. You know, whenever we are factorizing any quadratic expression, okay, we of the form ax squared plus bs plus c, we multiply the a and the c. Then we look for the factor pair of what? The product of a and c, which when you add, you get the b, which is the coefficient of the x. And when you multiply, you get what? The product of the a and c. So here 2 times negative 1 will give us what? Negative 2. Is that not it? So we'll be looking for factors of what? Negative 2, factor pair of negative 2, which when you multiply, you get negative 2, all right. And when you add, you will get what? Negative 1. So let's see, the factor pair, okay, 2 will be what? We know it will be 1 and 2. Okay, this will be the possible factor pair. Okay, however, because the product is supposed to give me negative, it means one of them must be negative. So it's either minus 1, 2, or 1 minus 2 to be the pair. However, again, if you add the minus 1 and the positive 2, what do we get? We get positive 1. But we want the addition to give us negative 1, not positive 1. So it means this cannot be the exact pair that we are looking for. We come to this one. 1, okay, plus minus 2. If you add the 2, you get minus 1. So this one, the product is giving us minus 2, and the sum, okay, is giving us what? The coefficient, which is minus 1. So this becomes the factor pair. All correct?
Yes, please.
Okay, so at this point, what do we write? We come and write this one as 2s squared. Then we split this one using the factor. So minus 2x, then plus x. Okay, then minus 1. We are factorizing. So at this point, what do? You know you group. Okay, Prof. Leslie.
Please, I don't understand.
Okay, this one, okay, this is something that you should have done in JHS. Okay, what will happen is, if you don't know how to do factorized quadratic expression, I will send, okay, the video on the lesson on factorizing quadratic expression. Then maybe use it as a guide. Because in JHS factorizing quadratic expression, okay, was one of the things that usually we like. Okay, so ordinarily, I shouldn't have done this straight away. We should have moved on, okay, to factorize. But because I think some of you will have issues, that's the more reason why I am trying to do this. So Prof. Leslie, okay, if you are not able to get this, no issues. Okay, prompt me to send a video on factorizing quadratic. Other than that, it's like I'm moving from functions to factorization, which is not what we are doing. You get the point? If I need to start
Yes,
from the
please.
scratch. Okay, so math is a build up. We build on. So whatever you learned in JHS, you shouldn't leave it there. Okay, you will need it here in SHS as well. In the SHS, we'll be dealing with complex questions or add on. So please, when we get to the point where you are supposed to make your JHS teachers proud, do so. All right, okay, so this is it. We factorize. So you split this one into this. Okay, I'll send you the video if you are still not there. So we group, after this, we factorize by grouping. And we group the first two and the last two. However, this is my advice. In JHS, usually you'll be asked to put the first two in brackets and the last two in brackets. Is that not it? So you show your grouping using brackets. But here, my simple advice is, don't use bracket to group. You can always avoid that because it can sometimes put you in trouble. Assuming, I'm saying this, assuming maybe I wrote what I have there as 2s squared, okay, plus x, I'm just minus 2x, okay, then minus 1. If I group this way, Okay, sometimes that's how you group, first two, last two. If you group this way, okay, you are wrong. In the sense that immediately you group this way, the negative is out, so this must be changed to plus. If you don't change this one to plus, you are doomed. And again, some of you will group this way. Another way of grouping, okay, will be assuming I have this. We'll group this way. If you group this way too, mathematically, you should know you are wrong. It means now this is multiplying that, so it's like you are through with your factorization, which equally is not carrying out the exact meaning that you have there. It's not depicting the exact meaning. So what is causing all these problems is because of the bracket. Don't, okay, use the bracket. Just come and pick the first two, factorize, and the last two factorize. So if I pick the first two, it means I am grouping mentally. Okay, so if I pick the first two and factorize, 2 is common, so I'll bring 2 out. S is also common, so I bring it out. Okay, then I will come and get x, okay, minus 1. Then if I come and group the last two and factorize, only one that is common. So I factor out 1. Then I'll be left with x minus 1. Okay, so in this case, this now becomes what? Okay, 2x plus 1, then into what? X minus 1. Do you agree? Is my point well made?
Yes, sir.
So after you are
Yes,
through
please.
with your factorization, then you import your results. Okay, your final, okay, result for the factorization. You come and bring it here. So that will give you 2x, okay, plus 1 in one bracket, and in another bracket, okay, x minus 1. Is that clear? And the reason why I advise you to pick whatever that you are going to factorize, which will not involve just a step in terms of factorization, okay, and factorize as a rough work, is that assuming you were factorizing the denominator, you can see that every step on the way, when you are factorizing the denominator, you have to write the numerator as well. You get my point. So it would have been, okay, maybe x into x plus 1, then over. Then now you come and write what you have there as 2s squared minus 2s, then plus x, okay, minus 1. Then it's equal to, you write the numerator again, then you come and, so you can see that anytime you are factorizing the denominator, you are writing the numerator as well, which will waste your time because your concentration should be on your interest, okay, is on the denominator. Meanwhile, every step on the way, you are writing the numerator, which will take your time. I don't know whether my point is well made. So here, if my point is not well made. Okay, I said, anytime you are simplifying any algebraic fraction, and you realize that in simplifying, you need to factorize either the numerator or the denominator or both. Okay, where any of the expression, be it the numerator, denominator expression, if it involves more than a step in factorizing, don't factorize it here. Take it and factorize as your rough work and import your results. You always write less and save time. Okay, because at this point, when you are factorizing the denominator, every step on the way, to keep the equal to sign, you have to write the numerator as well. But meanwhile, you are not interested in the numerator. You've already factorized the numerator. It's the denominator that you need its factorization. So go and pick it out and factorize as your rough work. Then you import your results. So it means if there is any mark for the method for the factorization, it will be given here because there is evidence of work for how you got, okay, your factors here. Is my point well made now?
Yes, please.
Okay, so at this point, you realize that we are through with the factorization. However, can we cancel anything? Can any of the factors cancel out?
No, please.
No. So it means this is how far we can go. Okay, because we are through with the factorization, we are now, okay, able to say convincingly that, okay, this cannot be reduced. So we end there. And at that point, we can draw our conclusion. So we are going to write, therefore, what were we asked to find? F of x over the g of, over h of x will be equal to whatever that you had here, your numerator being x into s plus 1, your denominator being what? 2x minus 1 or plus 1, I should say, into what? X minus 1. I guess my point is well made now. However, this happens to be your rough work. Don't forget to cancel it out. Very important. Okay, any questions at this point? Please, is there anyone here who can't hear me apart from Anna? Prof. Anna, please, can you hear me clearly?
Yes, please.
Okay, so Prof. Anna, please disconnect again and reconnect and check your audio because mine is working perfectly. The problem is not from my end, it's from your end. Okay, so work on your audio. All right. Okay, so that's it for what we have there. We are going to do one more. Don't worry, then your exercise will come. Okay, with that one, you should be okay, Prof. Paulette Paris.
Please, in this case, do you have to use a constraint?
No, it's not necessary. Usually we'll tell you that if the denominator that you have there is not, okay, I mean, it's not linear or it's more than linear, you can leave the constraint unless the question specifically asks you to attach the constraint.
Okay, thank you.
Okay, if it is more than linear, don't. It's not necessary. All correct. Okay, all right. Okay, Prof. Yasmin.
So if this question had required us to add a constraint, how would we have written it?
Okay, perfect. Okay, so very soon we will do that. Okay, we'll be looking at finding, okay, the value or values of what x for which a function is undefined. So very soon you will do that. So in actual fact, let me briefly talk about, you just have to, it means the whole of the denominator here should be equal to 0. So it's now should not be equal to 0. Okay, you set each one not to be equal to 0, then you solve for your x. So it means x should not be equal to -1 on 2. I'm doing that mentally. Or x should not be equal to what? 1. Okay, don't worry, we'll get there very soon. After this, that's what we will do after the algebra. So you appreciate it better there. Okay, so I almost allowed you to take the wind out of my sail. That's all right. Okay, so this will be it for what we have there. So now let's go and look at the last one. And I believe those of you who are not up there yet, with the last one, okay, your understanding will be better. Okay, so quickly, let me clear what we have there. Okay, I will need, okay, here's this space. So this should go. I've used this one to buttress a particular point. So that should go. Even this one, I said, it's not necessary. Okay, so anytime you are dealing with an algebraic fraction and you realize that you want to reduce, and because of reduction, you will need factorization. Please, any expression that will need more than a step in factorizing, take it out and go and factorize as your rough work, be it the numerator expression, the denominator expression, or both. Take note. Okay, so now I'm going to look at that of the D. So when you move from one sub-question to another sub-question, that's where you leave a line or maximum 2 lines. But all that we are doing here, steps to the same question. So we shouldn't leave any line unattended to. I'm repeating this just for emphasis because some of you are still doing the wrong thing. Okay, so D, what are we dealing with? H of x over what? F of x. Okay, so we know that this will be equal to, what is our h of x? H of x we know is what, the 2s squared, okay, minus what, the x, then minus 1, all over our f of x. And what is f of x? F of x is the s squared, okay, plus what, x. Okay, so at this point, we are more than good to go. You check before you can convincingly say, okay, you will be more than sure that this cannot be reduced. You have to express the numerator and the denominator, okay, in its factorized form. So numerator can be factorized, denominator can be factorized. But you can see that the denominator, just a step, okay, will give us its factorization. So I'll factorize that one first. So that would be s out, then x plus 1. Is that clear? But the numerator will involve more than a step. Okay, and the factorization, we've done it here, so I don't have to go through. So assuming this was a question that you've not done the factorization, then it means what you have done here, that's what you are going to do here. Then you import your result to the numerator, and that becomes the factorization of the numerator, which is what? 2x plus 1, then into what? Okay, x minus 1. Is my point well made?
Yes, please.
So again, we can see that, can we cancel to reduce?
No.
No. So this is how far we can go. We can simplify. So now we are more than sure that we can't reduce. So you come and draw your conclusion. Therefore, okay, what were we asked to find? We were asked to find h of x over over f of x. Okay, and that will be equal to exactly what we have here, which is the 2x plus 1. Okay, then into what? X minus 1 all over x into x plus 1. Afa, are we all fine? Okay, so
Yes, sir.
if you are fine, so it means now we know how to factorize x squared plus x. We know how to factorize x squared minus 1. And we also know how to factorize this. So any question that involves any of them in terms of division, you should be able to reduce it if possible, because in order to reduce, you have to factorize. And here we know how to factorize each of them. So at this point, if I give you this as your class assignment, there shouldn't be any issues. So please take note, this is going to be your class assignment. Okay, class assignment. Okay, so you are welcome back from the water break. Now we are going to look at our next concept. Okay, and here, this is what we are going to do. We'll be looking at finding the value of values of x for which a relation or a function is undefined or not defined. Okay, undefined or not what's defined. So these two, okay, can be used interchangeably. Undefined is the same as not defined. Okay, you need to take note of this. This is all that you need to know anytime you are asked to find the value or values of what? The variable that your function depends on, for which your function is undefined or not defined. This is all that you need to do. Okay, so for a relation or a function, so here we'll be doing more of functions, but remember, functions are relations, but not all relations are functions. Of the form f of x over g of x. So it means my function will be a rational function. Okay, and to be undefined, if this rational function is undefined, then it means the denominator must be equal to 0. So for every fraction to be undefined, the denominator must be equal to 0. You agree? That's why if you do 1 over 0, any number over 0, the calculator will give you math error, which is undefined sort of, or infinity. Is that clear? So just as you know, like I was saying, anytime I have any expression of this form, a over b, or any number of this form, this, okay, will be undefined when b, okay, is equal to what? Sorry, it's not equal, it's supposed to be equal to, I wrote not equal to. This is undefined when b, okay, so you let me write the not equal to, I can still use that one to make my point. Okay, so I can write, the simple meaning is that b should not be equal to 0. So it means, okay, this fraction that you have here, if b is not equal to 0, then that will give you the defined. The fraction will be defined. However, if the fraction is undefined, then it means b should be equal to 0. And that will, I wrote not equal to again. Forgive me. This time around, b should be equal to 0. And when b is 0, you are looking at it to be not defined. Is my point well made?
Yes, please.
Okay.
Yes.
So b not equal to 0 will make this fraction defined, but b equal to 0 will make the fraction not defined. So for any fraction, okay, to be undefined or not defined, just equate your denominator to 0 and solve the resultant equation. So if you equate the denominator to 0, then you've moved from expression to an equation. So you use your technique in solving equation to find the value or values of the variable. Okay, that's all. So quickly, let's go and look at our first example. It's not difficult. Here, basically, we'll be solving equations. Okay, and we'll end at quadratic equations. Okay, so this is what we have. Okay, find, the question said, the first question, find the value or values of s for which the following relations or functions are undefined. So you underline undefined. Very critical. So you've been given this a function, this a function, this a function or a relation, this a relation, this a function. So we are going to do maybe the first four. Remember, once this is in red, then it means it's likely to be for you. So quickly, let's move on to the solution. Okay. Solution, having underlined the salient part. Remember, we underline, okay, undefined. Please, at this point, I need your maximum attention. Questions are numbered because we equally want you to number your solutions. So major question number 1. With the major question number 1, do I have to, can I extract any information given there? No. So I will come and write the A. I don't come down and write the A. Okay, so 1A, I have an information that I can pick. Okay, so I'm going to pick that information. What am I giving? Okay, f of x to be equal to what? 3x, okay, plus 1 all over what? X what? Plus 2. Is that clear?
Yes, please.
Very good. Now, once we have this, remember we said for every rational function, okay, to be not defined or undefined, the denominator must be equal to 0. So just set the denominator function to 0 and solve. So this is what you do. You come and write 4. Don't straight away set it to 0. Write something, okay. So for here, the word there is undefined. So for undefined, okay, comma, your denominator function, which is x plus 2, should be equal to 0. Is that clear? This is the first example, so please take notes. But you don't end there. You come and solve for x. So this implies that, okay, here I can use implies that because I'm dealing with an equation now. So remember implication star for equations and inequalities. So I'll write x will be equal to, then I move this one, minus 2. So I'll write therefore x, okay, is equal to minus 2. And please take note, don't come and draw your conclusion that therefore the value of x, okay, is minus 2. No, this is the mass statement of that same, okay, statement. So just write x is equal to its value, minus 2. This means the value of s is minus 2. This will save more time. It will save you time. So don't write therefore the value of no, just write this. Is my point well made?
Yes,
Yes.
Okay, very good. This is the first example. So here, because the denominator, okay, which you set to 0, is a linear, okay, expression, you end up getting a linear equation after setting it to 0. And we are all experts in solving linear equations. So quickly, let's move on to B. Okay, B1B, what are we giving? Okay, g of x is equal to, my professors, I hope you are following.
Yes.
Yes,
Okay, very,
please.
very good. We thank God. So this is what we have. So don't straight away, just come and write something. Okay, so for us to know exactly what you are doing. Because if I just come and write s plus 2 is equal to 0, can't you see that there is a missing link there? You wouldn't know, why is s plus 2 equal to 0? You get it. But if you precede it by writing for undefined s plus, then you know it is making, okay, it is very clear now. So the person who takes it, okay, is able to relate. Okay, all right. So now what do we have for undefined? And use the exact word there. So for undefined, so it means if we had not defined, that's what we have used. For undefined, comma, our denominator function here, which is 3x minus 6, should be equal to 0 because we said if you want to find undefined or not defined, just equate your denominator function to 0, as simple as that. Afa.
Yes.
So after equating this one to 0, what type of equation do we have here? A linear equation, is that not it?
Yes.
And we are all experts in solving linear equations. So because this is a linear equation, what do we do? My next step here, I use implication because it's an equation that I'm working with. Or I can even ignore, no issues. But if I want to introduce, I cannot introduce equal to, but I have to introduce what? Implication. So now I will write 3x. I'm making x the subject, and I will move this minus to this side. I'm solving for x. So that will give me, or solving that equation, 6. Do you agree? You write it again
Yes,
before you
please.
divide. Take note of that. Anytime you are going to divide and you realize that, okay, to each side of the equal to sign, you have what? Just a term sitting there. You have to write it again. You can't do your division mentally. So you write that 3x is equal to 6. Again, then you divide by 3. You divide by 3. So at this point, I will get s to be equal to 2. I'm mature, so that will be my final answer. So I'll come and write, therefore, x is equal to what? This cancels that and gives me 2. I can write it there. Or somebody can come and write, okay, s is equal to 2 here before drawing your conclusion. Afa, are we all fine?
Yes, please.
Okay, all correct.
Yes, please.
Great,
Yes,
you are
please.
doing well. Keep it up. All right, so now that will be it for B. We have 2 more to go. Okay, so C. What are we giving? We've been giving y to be equal to what? 3x over, okay, 3 minus 2x. Okay, so again, you come and write 4, okay, undefined. Okay, I realize I don't have space there, so I will come down. And that will be my denominator function, 3 minus what? 2x should be equal to 0. So this is, okay, obviously a linear equation. I always, remember, I've told you, I always want to avoid working with negative. So here, because what I want to make the subject, that term is negative, the term involving that variable is negative, I'd rather move, okay, than maintain it here and divide by negative, which you can do as well. Okay, so I am going to move this one to the side just to make it positive, then I divide by positive. So this means, or this implies, because it's an equation, I can use implication. It's equal to what? 2x. So I move this one rather to the side. Then I'll write it again and divide by 2. Take note. Okay, so at this point, I'm going to get x to be equal to what? 3 on 2. Do you agree?
Yes.
But in drawing my conclusion, okay, can I draw my conclusion with, okay, s is equal to 3 on 2? Because I know I've given you a particular advice. I want to see whether, okay, the advice is well taken or was well. Okay, so what do I do? Very good. Okay, thank you, my professors. You know, I told you that you avoid concluding with an improper fraction unless otherwise stated. So here it is not stated that we should conclude with an improper. So we have to change it to the corresponding, okay, Maize numbers in our conclusion. So that will give us 1 whole number, 1 over what? Over 2. All correct?
Yes, please.
Okay, very good. All right, you are doing well. Keep it up. Okay, please ask questions if there are issues. Remember, I'm here because of you. Okay, take note. All right, so now, okay, we are left with the last one. Okay, and that will be the D. We need to do that one as well. Okay, yes. Okay, so Anna, Prof. Anna. Okay, so for a fraction to be, what do you call it? Undefined. Okay, it depends solely on the denominator. That's why we are restricting ourselves to using the denominator. It doesn't depend on the numerator. It's the denominator that will give you 0 for your function to be undefined or for any fraction to be undefined. I guess your question is well answered. Okay, great. All right. So now, okay, let's move on to the D. Let me see whether we have room for D. Okay, D, let's see what is going to happen. Okay, so D, and as a guide, because I need to do D with you before you can do the E. Okay, so D, what are we giving? Please mute if you are not given the opportunity to talk. You've been given the expression 1 minus 2x over, okay, and it's a relation anyway. Remember, every expression is a relation, and it's a relation, okay, with a special name, and we can call it a function. Okay, so this is what we have. Okay, with this, remember, we are looking for undefined. So you write for undefined. And remember, you don't leave any line unattended to. So it means from here, okay, this will occupy my first line, my second line. So I'll have 2 lines occupied. Okay, then the next line will be where I write for undefined. I don't leave any line, okay, unattended to. So for undefined, my denominator function, which is x into x minus 1, should be equal to 0. Is that clear?
Yes.
So if for nothing at all, we should all be able to end here. We know that the principle is that for your function, a rational function to be undefined, a rational expression to be undefined, the denominator expression should be equal to 0. That's all. That's all that you need to know here. Okay, so at this point, okay, we are working with what? An equation. And take note, okay, this is a quadratic equation, all right, only that quadratic equation, this expression is already factorized. And you know one of the methods in solving quadratic equations will be factorization method, where you need to factorize your quadratic expression, then set each of the factors to 0. But here, your quadratic expression here came in its factorized form. So you thank God, okay, some of the work done for you. So all that you need to do, or you need to know, is that anytime you have the product of 2 numbers, A, B being equal to 0, then it means each factor, at least one of the factors should be 0. So usually we write A should be equal to 0 or B should be equal to 0. You get it? Or I should come again?
Please come again.
Please come again.
You're waiting for me to say, ask this question. I don't like that, please. Okay, when you don't get it, I'm here because of you. Let me know. Okay, so remember, when you were solving quadratic equation, assuming maybe I gave you this as a quadratic equation, maybe s squared minus 1 is equal to 0. How would you solve this? Because this is factorable, you come and factorize this as s plus 1 into x minus 1 is equal to 0. Am I right?
Yes, please.
At this point where
Yes.
the factors, okay, you said the product of these 2 numbers, meaning the factors, giving you 0. What do you do from here? Who can tell me what you were taught to do? I want someone to tell me. After factorizing, what do? You set each of the factors to 0. Is that not it? And solve for the x. So meaning you come and write x plus 1, which is the first factor, set it to 0, or x minus 1 is equal to 0. So we are saying that what we are using here is what we call the 0 product rule. If I have the product of 2 numbers whose result is 0, then it means at least one of the numbers should be 0. So if one of the numbers, okay, 0, then it means 0 times the other number. If it's not 0, we'll still give you 0. You get it? So anytime you have products of 2 numbers giving you 0, then it means at least one of the numbers should be 0. So remember, we'll say that either the first number is 0, okay, or the second number is 0, or both are 0. But we go with, okay, first or second. So remember, I said either goes with what, or. So that's the more reason why we write the first number here, we write is x. So you set the first, okay, factor, which is x, to 0, or the second one, which is what, x minus 1 is 0. And please take note of this connector, or. In some books, you see comma and you see end. Please never, and I repeat, never in capital letters and bold as well. Okay, never use comma. or use what end. The connector should really be or. Take note of this. Am I clear? So you set each of the factors to 0. So the first factor, which is x here, should be equal to 0, or your second factor should be equal to 0. Is that clear?
Yes, sir.
Okay, so, and solve for x. With the first factor set to 0, x is already solved for because x is standing alone. But the second factor set to 0, x is not solved for. So we need to come and solve for x here. So x just below it should be equal to 1 here. You solve for x. So here you are going to get 2 values for x. So you draw your conclusion. Therefore, x is equal to 0 or 1. So meaning if x is equal to 0, your function will be undefined, okay, or not defined. Let's go back and verify what we did, okay, initially and see whether the values. So let's see. If x is equal to -2 here, what will be the denominator here? If x is equal to -2, if you substitute -2 here, you are going to get -2 plus 2, which will give you the denominator to be 0. And any number over 0 is what? Undefined. So it means indeed, if x is equal to -2, this will give us undefined. I guess my point is well made.
Yes, please.
Very good. All right. So
Yes, please.
with the same explanation, okay, if x is equal to 2 here, you are going to get 3 times 2, which is 6 minus 6. So that will give us 0, making, okay, this over 0, and any number over 0 is undefined. Okay, and you come and do same here. Okay, 3 on 2, that's what you have. So with this one too, because this one we ended up getting a linear equation. That's why we had only one value. Okay, but if you have a quadratic equation, you are likely to get 2 values, okay, or 1 value. Okay, so a maximum of 2 values. Take note of that. All right, so yes. Okay, so and this time around you have 2 answers because your denominator that you have there is a quadratic expression. Can you see that? Because if you expand this, you get x squared minus x, and that's a quadratic expression. And anytime you have a quadratic expression, you can get 2 solutions provided, okay, the solutions are distinct. And here you had 2 answers. So I guess my point is, so that's why the question asks you to find value or values. So it means there's a possibility of you getting either a value or 2 values or more than a value. You get it? So in this case, we had 2 values. Okay, so with this, okay, you should be able to do this, which would be your assignment. Okay, I mean, part of your assignment. Take notes. So with this one, you know, it means my denominator here should be equal to 0. And then it will be x is equal to 0 or 2x minus 3 is equal to 0. The first one, x is already solved for. Okay, and the second one, you go and solve for the x and conclude. Okay, Prof. Paulette Paris.
Sir, please, I don't understand how
Your line
you
is
got
bad.
1.
How what? I got 1. Is that what you said? How I got the 1 here? Paulette. Okay, so if I got you right, how I got the 1? Okay, remember
Yes,
you said you set each of the factors to 0. After setting each of the factors to 0, you don't end there. You solve for the x in each, okay, factor set to 0. So this one, you set the factor to 0. X is already solved for. So no work here. X minus 1 is equal to 0. Is x solved for here after setting it to 0? No. So you have to solve for x. So that means you move the -1 to the side, which will give you x is equal to 1. Clear now? All right. Okay, great. So now I guess we can move on to our next set of questions. So this will be it for you are welcome, my prof.
Yes, please.
Okay, so we are done with question 1. Let's go and look at our next set of questions. So you know, as you move on, I'll be adding little bones. Okay, bones gradually. So if you don't get this, please, okay, make sure you ask questions to get, because going forward, okay, the questions will be a little more complex or complicated or difficult. So now to our second worked example. Okay, Paulette, is your hand still up or is the old one? Okay, great. So this time around, find the values, or the second question, value or values of S for which the following relations or functions are not defined. So again, not defined, we underline that, okay, because we'll pick it and use it. So in this case, these are the functions and relations or relations. So quickly, let's go and look at, okay, the solution to the first one. Okay, give me some few seconds and let me do something. Okay, I think I forgot to do that. Okay, so we are going to look at these questions. So let's look at the solution here. That's exactly what you can see. Okay, there. Remember, first thing when you read, underline the salient part, so not defined. And we underlined it initially anyway. Okay, just to emphasize. Then questions are numbered. The first thing that you write is solution. If you don't write solution, I wouldn't know, okay, where your solution starts, especially those of you who write questions and solutions. Okay, please take note. Then the questions are numbered. Okay, so this question is numbered, so I have to number my solution as well. And please don't write answers. The answer will be the final result. What you have there is rather the solution, not the answers. Please take note. The two are not the same. Okay, so what do we have? Okay, two. Can we extract any information there? No. Okay, then what do we do? A. Okay, that's where we extract. So given, or you can even choose not to write the given, then just write your f of x. Okay, is equal to x plus 1 all over, okay, x plus 2, okay, into your x minus 1. Okay, please, your question. Okay, not that I have shelved it, okay, or I don't want to answer. Okay, along the line, I will see maybe that situation will come in, and I will address it. If not, I will still answer. Prompt me, okay, if I forget. Is that okay? Okay. Okay, fine. Thanks for that. So at this point, we start by writing for, and for what? The word there is not, okay, undefined. It's rather not defined. So we use the exact, okay, word in there. So that would be not defined. Though not defined and undefined can be used interchangeably. But remember, the advice is go for what is used in the question. So for not defined, okay, my denominator, which is x plus 2, okay, into x minus 1 should be equal to 0. So take note, anytime you have, okay, product of what numbers, in this case, factors. I have two factors, x plus 2, then what, x minus 1. Okay, anytime you have two or more factors set to 0, you can, equal to 0. It's just a matter of setting each of the factors to 0 and solving. And that will be your solution to the equation. But if the value here was 1, you cannot come and equate each one to 1. We don't have one product rule or two product rule or any other normal product rule. You only have 0 product rule. So it is when this number here is only 0 that you can equate each of the factors to 0. Is my point well made?
Sir, please can you come again?
Okay.
Yeah,
If I have A times B being equal to 0, we know that this means A is equal to 0 or B is equal to 0. We can write that. But if I have A times B being equal to 1 or any other number, I cannot say that A must really be equal to 1 and B must really be equal to 1. Or B must really be equal to 1. Yes, 1 times 1 will give you 1. But I can also have A to be equal to 2 and B to be equal to half. I will still get 1. I hope you get my point. So this will not be the strictly values of what your A and B, or the strict values for A and B. So you don't have any other normal product rule apart from 0 product rule. So it's only when this number here is 0 that you can, after factorizing, you can set the factor to 0. I guess my point is well made now.
Mm-hmm.
Is my point well made? Okay, great. So now you have factors, okay, equated to 0, just like the previous one, only that the previous one, it was x into something. This is a factor. Once it's in brackets, multiplying this. So it means the whole of x plus 2 is a factor, x minus 1 is equally a factor. So just set each of the factors to 0. Because this is an equation, I can start with implication here, or I can ignore just as I ignored, but I cannot start with equal to indicate my step here. So in this case, it means x plus 2 should be equal to 0, or, okay, x minus 1 should be equal to 0. So in this case, you've equated or set each of the factors to 0. We said after setting the factor to 0, you don't end there, you solve for x. Okay, so this is a linear. So if you solve for x, you are going to get x to be equal to -2 here. If you solve for x, you get x to be equal to 1. Do you agree?
Yes, please.
Okay, so at this point, we are going to get, okay, x, okay, to be equal to, I can draw my conclusion, therefore x is equal to -2 or the second value, which is 1. All correct?
Yes, please.
Okay,
Yes,
then you can still go and verify. Okay, let's go back and verify the other one. Okay, so this one. When s is equal to 0, okay, if you put 0 here, you are going to get 0. This will be 0 minus 1. So it will be 0 times -1. And 0 times any number is 0. So your denominator will be 0, making the whole of this undefined. So indeed, 0 is a possible value that will make this undefined. Then let's go to 1. If s is equal to 1, this will be 1 into 1 minus 1, and it will be 1 into 1 minus 1 is 0. So you get 1 times 0, which will also give us what? 0, making the denominator 0 and making the whole of this fraction undefined. So this is also a possible or another possible value of what? Of x for your function here or relation here to be undefined. Afa?
Yes, please.
But if you do the right thing, okay, you don't need to investigate. Okay, it's not necessary. This is just to for you to know exactly the meaning of what the statement. So let's see if s equal to -2, you get -2 plus 4. This will be 0. And once this is 0, irrespective of the value here, the whole of this will be 0, making the whole of the fraction here undefined. And if s is equal to 1, you are going to get what? 1 plus 2, which will give you 3 here. Then into 1 minus 1 will give you 0. So it will be 3 times 0, making the whole of the denominator also 0. And therefore, the whole of the fraction undefined. So indeed, -2 and 1 will be the possible values that will make the function here undefined or not defined. All correct?
Yes, please.
Great. All right. Okay, so we are going to do this, the first example, okay, for question 2. So let's move on to the next one. Okay, and that is what? That is going to be B. B, what are we giving? Okay, g of x. And remember, you leave a line, at least a line or maximum lines, when you are moving from a sub question A to another sub question. Okay, you leave a line. But these steps don't leave any lines. Okay, so will be equal to, they are giving g of x to be equal to 4x minus 2 all over what? 2x plus 1 as one factor, and the other factor is what? X minus 3. Okay, so remember, for, okay, undefined, do I write undefined?
No.
Okay, so what do I write?
Not defined.
Not defined, because that is what is appearing in the question. Please take note. For not defined, okay, comma, our denominator, which is what? 2s plus 1, okay, going into x minus 3 should be equal to what? 0. So if the question asks you to deal with for defined, then it means it shouldn't be equal to 0. You get it? It's the same thing. You just play with. Okay, so if the not is not there, the question asks you to find the values of x or value of values of x for which the function would be, okay, defined. Then for defined, okay, you need to write not equal to. We'll come to that. Okay, but that one will be done in relative math. Okay, so this is what we have. At this point, this implies, or I can ignore. I cannot write equal to. Then product of two numbers giving me 0. It means each of the numbers, okay, or the factors that I have here should be equated to 0. So in this case, I will write 2x plus 1 should be equal to 0, or, okay, x minus 3 is equal to 0. So at this point, what do we do? We come and solve for x, okay, on both sides. So solving for x here will be easier. So I always want to do the one that will involve letter or no word first. So x will be equal to 3 here. Then I come and solve for x here. So 2x will be equal to, I move this one, okay, the plus 1 to the side, and that will give me minus 1. I write it again before I divide. Over 2 over 2. So it means my x here will be equal to minus 1 over 2. But that is not all. I need to draw my conclusion. Therefore, okay, x is equal to, what's the first value? Minus 1 on 2, or the second value is 3. Okay, or somebody can write s, okay, should be equal to 3 or minus 1 on 2. It's the same thing. The other doesn't really matter. What is important is that we have the two numbers there. Is that clear? My professors, are you there?
Yes, please.
Yes,
Great.
please.
All right. Okay. So that one also cleared. We have 2 more to go. Okay. Then your assignments will come. Okay. At this point, okay, I'm going to pause any questions before we move on and do the C and the D. Oh, so all of you are fine. We thank God. You are doing well. Keep it up. Okay. So C. What are we giving? We are giving, what do you call it? H of x is equal to 3x minus 1, oh sorry, plus 7. Okay, all over x minus 4 all squared. Okay, so now you know, if for nothing at all, this one, we should all be able to write it. So for not defined, okay, comma, the denominator, which is x minus 4 all squared, okay, should be set to 0. So as for this step, we should all get it right. Is that clear?
Yes, please.
Okay. So now you can see that unlike the other one, where you had x into, so this one plus 2 into this, because the factors that you have there were not repeated factors. That's why we wrote them separately. But here you can see that this means x minus 4 multiplying itself twice. Am I right? So I can
Yes,
write
yes.
this one, I can take this one to my comfort zone, which is the x minus 4, okay, times what? X minus 4. Okay, being equal to 0. Do you agree? So now you come and set each of the factors to 0. Please take note, this is not the same as s squared minus 4 squared. You know, I've told you how to expand a binomial. Anytime you have a binomial squared, if you expand, you get 3 terms. Okay, but we are not interested in the expansion, because if you expand, you still have to come and factorize before you can set it to 0. Meanwhile, the question came in its factorized form. So why then do you go and expand? Take notes. So in this case, you come and set the factors to 0. So it means x minus 4 should be equal to 0, or x minus 4, okay, should be equal to 0. So in this case, you get x equal to 4 here, or x equal to 4. Okay, in drawing your conclusion, remember here you had repeated solutions, repeated values for x. But when you are drawing your conclusion, you discard one. So you just come and write, therefore, x is equal to 4. Obviously, it will not make sense for you to write x is equal to 4 or 4. Am I right?
Yes, please.
So you discard one. When you solve and you have two, okay, identical solutions, you discard one. Or if you have 3 identical solutions, you write only one and discard 2, okay, by extension. Okay, so this will be it for this solution. Okay, then we are going to, someone would have taken the square root here. If you are matured, another way, let me write it, so that if you see somewhere, you can appreciate. So you come and write, for not defined, you still have your x minus 4 squared is equal to 0. Then what do? The next step, take the square root of. It's just like you are doing change of subject. Once what you have is under a square, okay, or inside a square, you take the square root to get rid of the square. And you come and take the square root. Ordinarily, you should have written plus or minus here, but we don't have plus or minus 0. So it will just be the square root of 0. So this will give you, this will take care of that. So you end up getting x minus 2 is equal to root of 0 is 0. So you get s to be equal to 2. Oh, was it 2 or 4? It was 4. Am I right? So s will be equal to 4. Is that clear?
Yes, please.
Okay, which will land us at the same result. I usually use this approach because obviously you can see I wrote less. Okay, but because I wanted you to appreciate it better, because it's this direction that students appreciate. That's why, but you can do this, Salah. Okay, as well. And you draw your conclusion, therefore, s is equal to 4. That will be it for. So now, the last question, okay, for all of us. So which will be, we have, okay, let me write it here, D. D, what are we giving? We've been given 1 minus 2x all over x squared minus 4. Okay, so we know that 4, we come and write for what? Not defined, am I right? Comma, our denominator, which is x squared minus 4, should be equal to 0. So as for this one, we should all be able to deal with it. So this is a quadratic equation. Okay, obviously a special one, but you know, for every quadratic equation, the best approach, provided the quadratic expression, okay, to the left of your equal to sign is factorable, the best option will be the factorization method. So here, this is factorable, and we can use difference of two squares to factorize this. Is that not it? Because the 4 here is the same as 2 squared.
Yes.
So you are mature,
Yes,
you do that
please.
mentally. So what I'm going to write here, you can skip. Okay, I mean, writing it for it to be obviously difference of two squares. Okay, you can skip this particular step. Once you realize that this is the same as 2 squared, you can move to this step, factorize straight away. So s plus 2, then x minus 2. Because the factorization of this will give us what we have there. So here, what do? You set each of the factors to 0. So s plus 2 will be equal to 0, or x minus 2 will be equal to 0. Then you solve for your x. X here will be equal to 2. X here will be equal to, minus 2. Then the x here will be equal to 2. Is that clear? Then you comfortably draw your conclusion. You can see that your x values that you had there are distinct values. So you write all of them. You don't have repeated. So you write each of them in your conclusion. So minus 2. So we are going to get therefore x is equal to minus 2 or 2. Is my point well made?
Yes, please.
Okay, now
Yes.
take note. I would have dealt with it this way, which will be the alternative way. I'm going to do this, okay, up here. So when I have my s squared minus 4 is equal to 0, anytime you are confronted with a quadratic equation, and in that quadratic equation, you only have the s squared term and the constant term, meaning the linear term is missing, you can always make s a subject, right? So meaning you do change of subjects. This would have given me s squared is equal to, I'll move this one to the side, 4. I will come and take the square root, so it's square root of s squared, and come and take the square root here. Anytime you are taking square root, okay, you ask yourself the quantity that you are looking for, is it both positive, negative? Can you assume positive values, negative values as well? And here, any equation that you solve is possibly, you can get a positive value or a negative value. So you introduce plus or negative, and that will give you root of what? 4. So I'm going to get what? Okay, x squared, root of that will give me s equal to plus or negative, root of 4 is 2. So I'm going to get, therefore, I split. X will be equal to minus 2 or 2, or 2 or minus 2 is the same thing. You end up getting the same result. And I usually use this approach because, once again, I'll write less. Is my point well made? But if this one, okay, you can relate with this one better, please go for this one. It is always, okay, best to play it safe. Always go for your comfort zone before you move out of your comfort zone. Okay, all correct?
Yes, please.
Yes,
Okay, so on that note, this is where we are going to end. Okay, this is where we are going to end. Okay, so if you don't have any questions, okay, please, you wait for your assignment. I think the assignment, yes, I will ask you to submit. Then maybe I'll do the video and send it to you, okay, to check. So that's where, like, when you meet tomorrow, there wouldn't be the need to go over, okay, entirely the solution to the assignment. Okay, Jacinta, Prof.
Sir, please, the E. Before
The
we
E.
get the non-defined, like before we solve it, will you like factorize it before?
Yeah, so once you equate it to 0, it becomes a quadratic equation. Is that not it?
Yes, sir.
So at that point,
Yes.
you are working with quadratic equation. So you make your JHS test plan, solve that quadratic equation, and conclude with the S values.
Okay.
You get it?
Okay.
All right. Okay,
Yes,
so
sir.
whichever way you want to solve your quadratic equation, you solve. However, I just said that if your quadratic expression is factorable, the best method of solving the quadratic equation is the factorization method. Unless the factorization method ceases, that's where you resort to either the completing of squares or the quadratic formula, what we usually call the almighty formula. And remember, okay, between these two, okay, that is completing of squares and the quadratic formula, you go for the quadratic formula. For the completing of squares, unless, okay, you are restricted, don't use it. Prof. Nana Kwame.
Sir,
Your hand is up. The E.
could you, I wanted to ask if you can solve it without squaring the 4.
Which one? This one.
Question D.
B.
Yes, please.
B. This one. You mean this one?
D.
C rather.
Sir,
C
please,
for
question
cat.
D.
D.
Yes, sir.
He said, can we solve without what?
Squaring the 4.
No, did you square the 4 somewhere?
Hey, like breaking the 4
You mean finding the square
to
root?
2. Yes, sir.
Are you talking about this?
Yes,
where
sir.
is it? The D. Or D, where is it? Okay, are you talking about this?
Yes, sir.
Okay, this is your comfort zone. This is a quadratic equation. And I just said for quadratic equation, it's usually better if you can factorize your quadratic expression, use the factorization. So here, that informed this decision to factorize. You get the
Okay,
point. So, and
yes,
I
sir.
could see that what I have there here is difference of 2 squares. So I said this step can always be skipped. So once you see that this is the same as S squared minus 2 squared, you should be able to factorize straight away. So you can move from here to here straight away. But I wrote this just to, this is more or less an explanation step. Okay, but it's not necessary. You can always do that. So it means if I give you S squared minus 16, you should know that it is the same as S squared minus 4 squared. So that factorizes into S plus 4, X minus 4. Without necessarily writing this as S squared minus 4 squared. You get it? Before you factorize. Remember, I even said it in one of the questions when we had X squared minus 1, when we were factorizing. I said it's not necessary to write this as 1 squared. This factorizes into S plus 1, then X minus 1. Because you know that is the same as 1 squared, S squared minus 1 squared. Afa. Are we all fine? Is everyone okay? All right, thank you very much. Okay, so you wait for your assignments. Okay, so take notes and the video as well. Okay, so once again, thank you very much for your contribution. Okay, for making the class very interactive. God bless us all.